Hello, everyone. Good morning. We'll just wait a few more minutes to allow all of our panelists to arrive. I believe we had a question here from Fritof. I'm just going to allow you to speak.
Anya, while you're waiting, can I ask you a quick question?
Absolutely.
Are we watching all the presentations for both challenges?
No, so this is for challenge 1.
Okay, thank you. And are we expected during their presentations to do the score sheet?
I think it's good to take notes. We will be doing a little bit more comprehensive look into the score sheet during the deliberation.
Okay, thank you very much. Great, thanks.
Fritof, I believe you raised your hand. Do you have something to say? No. In any case, if you do have something to say, please write it in the chat because we cannot hear you, okay? No, we do not hear you. Okay, thank you. We're just waiting for our last jury member to join us, and then we will begin. Okay, all right. Okay, so in the interest of time and not wasting any of it, we will begin our pitch competition this morning. I would like to first welcome all of you who have joined us for the opening ceremony and those of you who have not, especially the audience who may be joining us through the WOVA platform. Thank you for joining us, and we hope you like what our teams have put together this morning. I would also like to mention to you all that the Business4Change Hackathon is an initiative of the European Commission DG GROW, and in working with DG GROW has been VVA and the European Business Summit, of which I am a part of. All right, let's begin. So we will be going through challenge 1 today. Challenge 1 is a challenge that the teams, I will just detail a little bit later. The teams for challenge 1 are the Flip team, the Hackastic team, and the Limitless Circularity team. Following their pitches, we will have a short coffee break, and then we will go into challenge 2. So I have been given a few of you the right to talk, as well as our jury member who have all been allocated to panelists. For the teams who would like to share their screen during the presentations, if you have not told me already, or if for some reason I do not know that who should be put on panelists, please just raise your hand or make a note in the chat and I will do that for you. Please note as well that the session is being recorded. There may be a few of you using video during your presentations, and in case there is an issue with the sound, I have also added the videos to my presentation as a backup. So let's just dive in very quickly. What is challenge 1? Challenge 1 is where the teams have been asked to reduce the supply chain cost of waste plastics packaging. This challenge has been come to fruition with the support of SUEZ. The key to this challenge is that it requires looking at the logistics costs across the entire supply chain, and that the overall goal is to collect more plastics and have a positive environmental impact. thereby decreasing the CO2 emissions and as well the emissions linked to transport. I would like to introduce our jury members today. We have Philippe Dehart from SUEZ. He is the Europe Innovation Officer. We have Celia Moore, a CSR consultant. And we have Alberto Massetti Zanini, who is the Global Development Director from Impact Hub Network. If you guys would like to also introduce yourselves, Philippe, you may say a few words if you'd like.
Morning, everyone. Hope you hear me well. Yes.
Yes.
Okay, great. It's a pleasure to be here. And so, as Adibis said, so I work for SUEZ for about 10 years now. Actually, I'm Europe Innovation Officer. It means that I'm mainly in charge of the coordination of all our collaborative research and innovation strategy. Thanks.
Many thanks. Celia, would you like to say a few words?
Can you hear me now? Yes, good, thank you. Good morning, everybody. Very excited to be here. And I think this is a really important and significant challenge that the teams have taken on. I'm Celia Moore. I'm a CSR consultant, and I work very much on the interface between Europe and Africa. I worked for 20 years in IBM, so in the context of lots of IT and innovation. I managed our programs in the community, looking at new ways that technology could be used for social benefit and focusing on education. So this is a really interesting challenge. I've always been fascinated around the need to push harder on the circular economy, and I think this is the direction we're going. So very, very good. Thank you.
Thank you, Celia. And Alberto, your turn.
Hello, can you hear me? Can you hear me at all? Hi. My name is Alberto Massetti Zanini. I am the Global Development Director, as you were saying before, of the Impact Hub Network, which is the largest network in the world supporting social entrepreneurs. Entrepreneurs, of course, that are like yourselves, addressing social and environmental issues in the world. And I've been with the Impact Hub Network now for like 13 years, and I'm one of the dinosaurs of the system. I'm one of the makers. So very excited to be here today. Thank you for the invitation.
Wonderful. Thank you very much to our jury members for joining and for their expertise and insights that they will offer our teams. Okay, so without further ado, let's dive into the first pitch presentation, which is from the Flip team. I believe Margot would like to share her screen. Otherwise, I will also have it here. So I'm just going to enable you to do that, Margot. You should be able to share your screen, Margot.
Hi, everyone. Yes, I think it would be better if I could share my screen. I could see the videos. Who's disabled? I can't share my screen apparently.
Okay. Just one moment then. I have promoted you to panelist, which means that you should be able to. I will make you a co-host, which should help as well. Okay.
Yes. Okay, now it's working.
Perfect. Just a reminder to all the teams, before we begin, you have 15 minutes and I will start the clock on my phone.
All right. Can you confirm that you're seeing my screen?
Yes, I can see it.
Thank you very much. Okay, so let's start. Hi, everyone, and thank you very much for being here. We are the team Flip with Daniela, Joanna, and myself, and we are all currently studying sustainable management of resources in Ghent in Belgium. So here we are going to present our solution to answer the challenge 1 of this hackathon, in order to improve the plastic waste management in the health sector, as we decided to focus on hospitals mainly. Also, as a preliminary remark, I wanted to insist that when we talk about plastic waste here, we talk about non-hazardous waste only, because the hazardous waste is really regulated differently. So we are only tackling the clean waste here. So first of all, if we really want to understand and to have an idea about the plastic waste burden in hospitals, it's important to have in mind that plastic waste is representing 20 to 25% of their total waste. So it really depends on each facility, but globally we can estimate that every hospital is producing several hundreds of tons of waste every year. The main issue is at the really beginning of the chain, because as you know, people working in hospitals are there to save life and not really to save the environment. So basically there is really, really little effort provided for sorting the waste within hospitals. So our goal is to optimize this chain and to optimize the costs as well, because when they send all their mixed waste to big sorting plants, they will have to pay fees for that. As an additional remark, we wanted to say as well that the current pandemic is making this challenge even more accurate and actual, because the single-use plastic is even more and more used in hospitals. So here we made a little diagram just to have a simple idea about hospital produced mixed waste with an estimation in weight for films and rigids. Everything goes together in this container, which implies cost and collection costs, and then goes to energy from waste plant, where the plastic has to be removed and sorted, and the associated fees. So here in hospitals, we have basically no time, no space, and limited budget because other priorities. So how are we going to tackle this problem? We decided to plan our strategy under three main directions: help the personnel to sort rigids and films out of the residual, then to gain space and to save costs, but also to focus on one specific plastic stream that can be recycled. So we've been in contact with different suppliers, and our solution is actually integrating different developments, technological developments at different steps of the chain. So first of all, for the sorting, a few papers have shown that transparent colored bags are actually the most efficient solution to help people to sort trash and waste without thinking about what bin to choose. So we are really aware that you might think it's a déjà vu, but actually the innovative aspect of these bags is the fact that they are endless garbage bags. So you can put waste in it, but then for the manipulation, collection, you have this system. So I'm going to start the video, hopefully it works. So basically you can collect it by the bottom, so you are never in contact with the waste. And for plastic waste such as film, for example, you can compress it with no risk at all to be in contact with the waste. Also, you are sure that your bag is like 80%, 90% full, and it's not like the current bags that we use in hospitals that are always half empty. So this way of collecting, sorting plastic waste within the corridors and hospitals and reception area would allow a smart, quick, and a safe way to collect plastic in a separate streams than the residual. So for the colors, well, everybody is free to choose, but basically we want to avoid the red and the yellow bags, as it's already dedicated for other streams in hospitals. And we would like to, for example, white for the films, green for the rigids, and remain with the usual standard black for all the residual. So this solution is for us a gain of time and also a gain of money, obviously, and it's providing a safe environment for workers. So these bags can be collected, and then instead of putting them in the container all together with the residual, we would like to dispose them in this container, which is actually a compactor with 2 compartments. It can be 2, it can be 3, it can be 10 if you want, and you just have to move the press at the top of it in order to compact the waste. and to actually reduce the volume by 7. So here in the video, the example is made with plastic films and cardboard, but you can also use it for plastic rigids, and it's working the same way. The good advantage of this is you can really adapt depending on the waste that you want to compress, but then you have a really, really big saving in terms of volume. So obviously the container is not going to be as full and you're not going to transport air. So this solution, the bags, so they are perforated, so you can compress them. And the compactor aims to have economy in terms of space and cost. And then at the transfer plant, you would have these big ballots, which are green, transparent, and actually really help for the sorting. So on top of that, we actually realized that there is one really big issue with the sterilization wrap. So the sterilization wrap is this blue wrap that is used to manipulate sterile material. So here we are talking about pre-operation stage. So before surgeries, the nurses are always opening and handling and transporting all the sterile material with this wrap. And it represents between 5 and 6% of the total waste of hospitals. It depends on the hospital actually, but it's really, really a big issue, especially when we know that polypropylene can be recycled easily. So Flip proposed that we could, at the pre-operation stage, collect all these wraps within the same endless bag system. And it could even also help to compress it, because as you can see, it's really, really big. And then these bags containing the clean wrap could be transported to a recycling unit that has been designed in the UK by TCG. And the name is Terramelt, and would allow to recycle this polypropylene and to produce new bricks of 100% PP, then can be sold to the plastic industry to be reprocessed. So obviously this machine is not cheap, but here we propose that the sharing economy model could be implemented in the health sector. That would help hospitals to share investments and also operational and maintenance costs. We also think that because this machine is actually, the capacity of treatment is bigger than only one hospital needs. So we think that it would be optimized in terms of resource, space, and energy consumption. And hospitals would also need to organize a collection and distribution system together. But thanks to this sharing economy model and dedicated technology, we would lead to loop clothing for the PP, and new plastic wraps would be produced from the waste. So obviously this solution has risk, which is not only the budget and the cost, but the main issue and the main risk for us is from the human side. Is actually from the lack of commitment, because even if we think that everything has to start from this, we are really realistic, and we know that in this working environment, it's hard and it's pretty complicated to make everyone having a really big concern about waste treatment. So that's a risk that we hope we could tackle with education, assessments, and workshops to really prove that it's possible thanks to dedicated solutions, and that it brings benefits in terms of environment, but also in terms of work environment actually. The other risk is for the share economy model, but it's the same risk for any business model following this sharing system. We could be afraid about the poor collaboration existing between hospitals and healthcare facilities, but we think that it could be tackled with the implementation of solid contracts and targets to follow, and also a transparency and good communication about all the benefits that this type of model would bring to them. As an underpinning really important dimension, a dedicated service, because we think that as any time you want to change the habits in a big institution, you need to have people to represent it and to really implement it on the field. So that would help this solution to be implemented and to have sustainable management. So now the numbers, because it's actually not too bad, and we are pretty happy to show it. Hopefully there is not too many mistakes, and it's pretty rough estimation. But basically here we have the current logistic costs. We are based on 60 tons of waste per month, and the 5% film and 20% rigid. So we included the rental of the container, the collection of the container, and all the sorting fees for the total waste. And you can see that we are around 120,000 euros a year. So here we'll try not to give all the numbers, but basically we made a list of all the investments that we would need for our solution, what the savings would be, and also the revenues that we could generate from the polypropylene bricks. What is interesting is the compactor is not really expensive. It's 14,000 euros, which is not tremendous. The Sterimelt unit is more expensive, but with our idea of sharing economy, we would be able to reduce this investment. And then for the sorting fees, so the savings, you can see that there is really a big difference if you sort between 50 or 100% of the plastic. So basically, if we look at the investment costs, you have here the total amount of the initial investment. It doesn't include the commissioning, training, transport, whatever. So it's really rough, primarily estimation. And if we look at the future chain costs with this compaction, handless bags, and recycling, we reach a reduction of the total cost. So basically, these numbers show that there is a reduction possible on the overall chain. And even if we can't recycle 100%, not recycle, if we can't sort and separate 100% of the plastics, we can still reach some improvements. The investments with our solution are realistic, they are feasible. It's not something that is impossible, and maybe it requires human involvement, but on the budget side, it's something that is for us realistic. And of course, for the beans, the negotiation has to be done because it really depends on the quantity. So here on this final diagram, you can see our complete solution. So basically, we try to tackle the challenge at different steps. We really think, and we are really convinced that if we really want to change the habits and the waste management system in the health sector, it starts with education and the change of the perception of waste management. And so yeah, our solution is for us feasible. And okay, I'm sorry, I lost the track. Someone entered for the final. So yes, okay, you can see everything here. So we think that it's possible to tackle the plastic challenge if we really focus on dedicated solutions. And it doesn't have to be only one solution. It can be little simple solution at different steps. And also the sharing economy model must be implemented in the health sector, as it would really open new doors for hospitals to access new technologies and to work with their suppliers to dedicated solutions. And actually, it's something which is already done in other sectors for plastic treatment, but also for industrial solutions. So we are convinced that the sharing economy model, as part of the circular economy, would be a great solution to tackle this plastic challenge. So I thank you very much for your attention. I thank also all the organizers, the experts for their help and the critiques and encouragement during the whole hackathon. And thanks for the jury to now ask your questions. Thank you.
Okay, great. So now we have 5 minutes for questions. I will just quickly remove you from being the host. and you and your colleague Ioana are both able to speak. Jury members, you're welcome to go ahead right with your questions.
Anya, I have one question, not a complex technical one. I just wonder whether the team, they've obviously very clear of the issue about from an HR perspective, getting people to take this on board, because obviously people in hospitals are very busy, and they're there looking after patients. But in an area like this, did you think at all about how you might, as part of the process, identify some champions, so that there's, as well as education and so on, that you would really look at some way of incentivizing some champions to really push this? Because I think what we observe in the area of circular economy and environmental management is that some people are passionate about it, and they might be willing to take on those roles.
I'm not really familiar with the champion's name.
It's someone that is environmentally conscious.
Well, it was our idea with when we talked about the risk, and we said that we think that there is a real need for a new service dedicated to waste management. So yes, we really think that some people, not an external company, but actually people from the environment of health sector should be dedicated to the waste management somehow. Yeah.
And actually, this is what happens now in Australia, for example. This is what they do. However, I think it's important, but I think that there must be a collective approach. And it's, one person is good, but I think all of them should be more involved. I don't know.
Yes, indeed. I just think that, one of the things we did when I was at IBM, we were looking at the issues of sexual diversity, LGBTQ, yeah? And so we found people in the organization who would be champions and, spread the word, say, I believe in this, join me. And that was quite an effective approach.
Yeah, we agree, and we think it's really, it must start from champions, and then spreading the message and increase the awareness and everyone involvement in every little step. Yeah.
Thank you.
Thank you.
I have a very quick question. So if you were to win, what's the first thing you will do?
We didn't even think about that.
If we win, well, we will be happy.
No, we are all students in second year of master right now, and we are working with different type of challenges. So plastic is one of them, but we work with the challenges in mineral industry, mining industry, in the chemical and water treatment. So, well, obviously SUEZ and Plastiwin represents something that would be a working environment for us in the future. Hospital and plastic is something that we are really concerned about, but I don't know about professional career later. So,
but I'm thinking, you mean what is the first thing that we are gonna implement in a hospital, if I'm not mistaken?
Well, first of all, if it's not if it
was, then it's not up to us.
But yeah, I think the first step, like as mentioned during the pitch, is very important, the education factor. And we truly believe that a change like this in a problem that is so complex and involves a lot of actions in the whole management waste should go back to the main root problem, and that is education. Not because people working in hospital are not educated, but in terms of most of them don't know their responsibilities, are not aware about the duties around waste management. So I think that will be the very first step, informing people about the environmental and economic factors that proper waste management in a hospital it could bring to them if they would properly perform it. So I think that's the very first step. Doesn't matter the solution that will be presented later or so on. We truly believe that it's based on informing and educating people.
Thank you.
Yeah, thank you.
Okay, Philippe, if you have a very quick question, we may take it. Otherwise, we will need to move to the next team.
Oh, it's okay. It was really clear. We can move on. Thanks.
Thank you. Thanks, everyone.
Thank you.
Okay, we have an additional question from Christine, but we will take those additional questions at the end if we have them. So thank you, Christine, for putting that in the chat. In the interest of time, we will move on. Thank you very much to the Flip team for their presentation. The next team to present is the Hackastic team. If you would prefer to share your screen, you're welcome to raise your hand now. Otherwise, I have your presentation queued up with the video, so it should also work from that angle. Okay, we will do that then. Okay. Okay, so from what I understood, we would begin the presentation with this video and then you will begin to speak. Okay,
Yep,
wonderful.
correct.
Hi, Tamas. Hi, so good to see you too. You know, I'm writing my thesis on circular economy and waste, and I need your help. Tamas, you're still the hospital manager in Brussels, and have you seen they put a container on your parking because they can't keep up with the volume of waste produced in your hospital? Is that true?
Yes, unfortunately, it's completely true. And indeed, it's a burning problem right now in our hospital. That you know, in whole Brussels, we have 9,000 beds, and we produce almost 2,000 tons of infectious waste and almost 10,000 tons of non-infectious waste per year. And I really would like to do something about it.
Well, that's indeed a lot. And what happens to all this waste?
Well, so that's also the advantage now we have Anne also with us. So she's an expert. She's from Unlimited Recycling. So let us hear what she says about what happens to all this waste.
Yeah, unfortunately, all what is infectious waste gets burned. It's dedicated incinerator.
Okay, and could you recuperate something before burning it?
Well, you know, it's infected, so you don't want to have more disease or virus going on, right?
Yeah, I mean, I have to admit it that, you know, hygienic is top priority for every hospital, and especially in this environment. So we need to be very, very careful on how we treat these materials. My first idea would be, why don't we start with metal? I mean, metal seems to be something easy to recycle. What do you think?
Yeah, metals are easy, and we could create. We could call you the head of the urban mining of the hospital, but you know, metals are so easy because they have value. As soon as something has a value, you can collect it, you can invest and sort it, and yeah, I want to go for something a bit more difficult, a bit more challenging for my thesis.
Okay. If you want something more difficult, so I mean, we can look at plastics, of course. We are using more and more plastics. And what is making my life very difficult that we have around 40 different kind of.
We lost audio. Anya, do you hear us?
Thomas, I heard you then, but I can't hear you now.
Yeah, I mean, it's a video, so it's from the presentation. So it's from Anya. She did something and we lost the sound of the video.
in the hospital gets
Sorry, everyone. Was it because I muted my sound that you lost the sound of the presentation, perhaps?
Yes, that's it.
Okay, that's my apology, sorry. Okay, let's just go back a little bit.
Yes, please, thanks.
I believe it should have been.
Yeah, I mean, I have to admit it that, you know, hygienic is top priority for every hospital, and especially in this environment. So we need to be very, very careful on how we treat these materials. My first idea would be, why don't we start with metal? I mean, metal seems to be something easy to recycle. What do you think?
Yeah, metals are easy, and we could create. We could call you the head of the urban mining of the hospital, but you know, metals are so easy because they have value. As soon as something has a value, you can collect it, you can invest and sort it, and yeah. I want to go for something a bit more difficult, a bit more challenging for my thesis.
Okay. If you want something more difficult, so I mean, we can look at plastics, of course. We are using more and more plastics. And what is making my life very difficult that we have around 40 different kind of plastics. And honestly, you almost need to be a chemical engineer just to understand what's going on. So, Anne, what do you think? What are our options?
Yes, as you say, I mean, it's too many plastic, very complicated to sort it, a very limited value because the recycling cost is fixed while the price of virgin plastic is linked to oil, so very volatile. So most of the time it doesn't even make sense to collect it.
True. It looks like it's impossible to sort and economical, hard to put it alive. But speaking of sorting, why don't we just start by just making sure all PET bottles in the hospital gets collected in a blue bag? That would be a start, and a visible one. It's the same as what the people do at home.
Yeah, sure. But for example, in some local areas or some local legislation obliges that all what is PET which has been touched by the patient is considered as dangerous waste. So you need to burn it. And in the top, you really have this extensive producer responsibility, which make that this waste in the blue bag is not even the resource of the hospital or the one collecting. True. So it's complicated legal framework.
Okay, I get it. No PET bottle idea, but I mean, there are some special plastic streams in the hospital. I mean, all these intubators, all these tools, all these Baxters. I mean, something could be done. Is there anything happening around us, Anne? Do you know something?
Yeah, sure. I mean, there have been some initiative to collect all the sterile clothes in Belgium, and that is done by protected atelier. So I mean, then you can recycle and it's reused in appliance. Really super nice ideas.
So it's already happening, and some people are finding it. Tamas, do you think we could do something?
Well, I mean, so the more I listen, the more I realize that indeed we need to do something, and I really appreciate the different level of knowledge and the different areas of knowledge that you all bring to the table. So I really would like you guys to get together and come work with me and put together our ideas.
That looks like a good idea. Anne, are you in?
Yes, sure.
All right, let's go for it. Hi, Tamas. Hi, Anne.
Hi.
Okay. Thank you, Anya. We'll start our presentation. So we start with this video, and then after a number of evenings and thinking sessions, we come up with a certain value proposition for which you can move to the next slide to go ahead. Good. So what do we suggest hospitals to go for? First of all, we would like them to be able, for once, to decrease the infectious waste fraction of their total waste, and then also to be able to increase the recycled percentage of their total waste, meaning plastics, as mentioned in the video. So first of all, why do we want to decrease the infectious or hazardous waste fraction? Well, it's mainly a money question, which Anne will show you in slide number 2 with the financials. But it's also, once you invest in such a decontamination machine and put it in the hospital, you go for a mid-term, long-term partnership with the hospital, opening the frame to go for smaller pilots and smaller projects. And Since you have done something to help with the cost, you're also a bit more free to go for small projects, which at the start will not necessarily help the total cost of the hospital. Hospital's goal is still to save lives and not spend too much money doing it. So that's how you can position it. Third point, once you decrease the infectious waste fraction and you decontaminate part of this waste, you also have access to possible plastics which before were contaminated, which aren't. So as long as you have a cost-effective way of sorting it, you could get your hand on those streams. Now, secondly, how do you want to increase the recycled content of this total waste stream? What do we want to take out to be able to recycle it later on? Well, you have two solutions. Either you have products present in large numbers, easily handled and recognizable, such as the sterile cloth that we found is happening in Flanders and that Flip presented, or some surgery tools such as those basins that you have on the top right corner of the slide. You could also go for smaller appliances, intubators, applicators, which are now being used in mass numbers in intensive care, but it's a bit too small to go for a first pilot. So those ones, since they're easily recognizable and easily handled, can be selected beforehand in dedicated bins and can be either decontaminated in batch or directly transferred, just as it's already happening for the sterile cloth. Secondly, you could also recover plastics from the decontaminated stream that you just decontaminated. Now, of course, what you can get out of this stream is decontaminated and shredded, so it's in small pieces. It needs to be cost effective. And presently, the one that we found is already happening is that the yellow polypropylene of the hospital bin itself, well, it's yellow, and there's not much else yellow plastic in that stream. So by optical sorting, you can get the PP out. Now you'll see in the financials that basically, as long as it's a pilot volume, both on sterile cloths, surgery tools, or even the yellow PP of the bin, it's almost insignificant in the total financial picture. So there needs to be several hospitals partnering, and but that can only be done once the pilot is proven. Now I can give the word to Anne to give you a bit more insights on the financials of the decontamination machine and investment on the next slide.
Yes, so from the financial perspective, our value proposition requests an investment of 300,000 euro for the contamination machine. The equipment we have selected is from ABM Belgium, and the machine is already installed in several countries in Europe. The payback is 5 years based on the treatment of 187 tons per year, one shift operator, and working 5 days a week. The profitability comes from the price difference between handling treating hazardous waste versus non-hazardous waste. So the beauty of this value proposition is basically that all the benefit coming from the recycling of the plastic itself is a cherries on the cake and can therefore be invested in something else, like an app for to increase awareness and incentivize people to better sort, that Thomas will discuss afterwards. The other interesting point for SUEZ of this model is that it creates a long-term commitment between the hospital and SUEZ, because obviously you need to have the machine installed. The machine weighs 5 tons, so you cannot move it easily. So you need a place at the hospital, and you need a 5 years commitment at least to recover the price of the machine. So I let the word to Thomas for the next slide.
Yes, hello everybody. So my background is technology. So I'm a technology delivery manager at Accenture. And so when I was connecting with my friends who are expert more in the chemical industry, I wanted to bring my technology added value to the team. So a lot of things are reality now, which are relatively easily accessible, but nevertheless we call the slide dare to dream. So that's not necessary for tomorrow. So that's not a short-term vision. But I'm 100% convinced that that within 5 years we can easily achieve whatever is written here, and of course, subset of the goals could be achieved earlier. So computer vision and machine learning is really in the industry becoming more and more accessible, Nowadays, in our mobile phone, we have a supercomputer. I mean, we have the capacity of a supercomputer 10 years ago. So this we would like to leverage in multiple ways. So we can imagine that we would support the most difficult part of reusability, which is sorting. So as I mentioned in the intro, so we have so many different kinds of materials, especially plastic. It's difficult to recognize for a human being without being an expert what it is about. So we can imagine an application, a custom-built application. You know, every smartphone nowadays has a mobile phone. So with computer vision and machine learning, we could help the individuals on the floor to recognize what kind of plastic it is and where to put it. So that's one idea. The second idea, to leverage computer vision and machine learning, that we could imagine building a standard container filled with technology, which is using computer vision to recognize the unsorted plastic once it's dumped, let's say, into the input of the container. Then we would use computer vision and robotics to sort it. And let's say the output of this container would be the sorted material, which after they can shred it, after it can be shredded, and of course it increases heavily the value of transportation because we remove the air from the material. So that would be a deployable container, movable, rentable, whatever business way of operating we could imagine. Also it would just on a truck. So that's about sorting. We could apply KPIs. So we could apply KPIs and we could motivate the individuals. So if the individuals are using, let's say, the mobile phone to scan plastics to determine which bag it should go, we could reward them. So we could use the so-called gamification in the application, and that would indeed identify automatically, let's say, champions. We could indeed also reward champions. So people on the floor who take the effort to scan and better sort, you know, could go, you know, expert level, could go next level, and we could even imagine rewarding them with things which could be useful in the hospital environment. For example, teddy bears, for example, better coffee, whatever which motivates them. And that could be, of course, financed from the value added with the better sorting. So other than sorting, we believe also the self-driving vehicles could also be leveraged eventually. So self-driving vehicle, not only for the transportation between the sites, but also in the site itself. So we have logistics environments, let's say Amazon, for example, is already transporting within its facilities with robots the packages. So this could be also leveraged also in longer term hospital or any other environments. So these a little bit or midterm vision after the quick wins presented by my colleagues.
And if you can go to the last slide. Yeah. Oh, it's a bit zoomed. Anyway, thanks for listening to us. I will quickly wrap up. On the first slide, the quick win presented by Anne and myself will be to go for decontamination part of the stream and sort whatever makes sense financially to have it now, or even makes sense from feasibility, like the sterile cloths or the surgery basins and so on. Because the more you start, the more you get, and you get the people involved. One important thing, we mentioned the example of the PET bottles in the video, which is a bit more tricky than it sounds. But out of all the interviews we had with doctors and nurses, it's the one that's coming back. So if you go and say we have an incentive to collect more of this and this and this plastics in the hospital, you should at least also have something for the PET bottles, because that's the one both patients, nurses, and the rest of the staff have in their mind when it comes to recycling. Now, to help them on this awareness, the application, it can either be a long-term vision as mentioned by Tamas, or it can be also a more easily low-hanging fruit of just having the way of gamification or having the champion, which has brought so many of the plastic this week or this department, not rewarding with money, as Tamas said, but you could go either copying systems that already exist with teddy bears or separate things. But we see this awareness and gamification needed for streams, which you'll need to convince the people. If you go for big things like the sterile cloths or so, then people do it on their own after a while. But if you go for some specific little things, then we really see the benefit of the app. Regarding profitability, if you're like me, you don't see the 2 points below the slide, but basically what we mentioned is that to make it more profitable and to focus on those plastics, plastic needs to get metal status, being that needs to be some value to do the work, because as long as it's less value, then it's not worth investing in high technology to get it out. So that's the way it can either be done by a legal framework or by helping on some market incentives. Now we'll be glad to hear your questions. Thank you for your attention.
There's one question from Christine in chat. Alexis, Anne, if you could have a look, please.
Yeah. So for the 187 tons of material, it's both calculation with some process reliability and hours of operations, but also actually it's the tonnage per year proposed by ECODAS on their website for the machine in question. So both the simulation and what the supplier says we should get from tonnage per year is the same, which is 187. Now, for the treatment costs, we don't have access to the real treatment costs or the quote from the hospital, but that's the ratio of 3.5 between infectious hazardous and non-hazardous is what we found in several articles and also lately published in March, the one about Brussels. So I'm not saying that 195 is the correct price, but the ratio between the two, which also makes the way of having a positive way of investing in the decontamination stay similarly the same overall.
Just to reiterate for the audience, Christine asked the question, how did you come to your proposal variable treatment cost of 195 euros per ton to the hospital? And can you remind us what is the 187 tons as material, just for the audience? Okay, for our jury members, if you have a question, please just shoot.
I'm going to ask you the same question that I asked the previous team. If you're the ones who win, what is the first thing you will do?
I was waiting for this question because I was in a listening, and so I already formalized my answer. So I am from Accenture, and so as I mentioned, so this computer vision and automatic sorting in a container, I don't see it being very far in the future that we could actually have it ready. And I think I would like to create a prototype, not on a scale of a container, but scale of a table, an office desk, that with computer vision, again, as I mentioned, for example, just with a smartphone, to start training an application on artificial intelligence, and then be better in recognizing plastic materials based on photos.
Thank you.
Do we have any questions from Celia or Philippe?
I don't have any questions. Thank you very much for a very interesting presentation.
Okay, wonderful. And Philippe?
It's okay from my side. Thanks.
Okay, great. Then in that case, if we have no more questions from the audience, we will continue on to the next presentation. Thank you very much, Hackastic team.
Thank you.
Thank you.
The next team is Limitless Circularity. Limitless Circularity, I will add you to be a panelist, which means that you will be able to talk. If you would like to share your screen or share the presentation, please raise your hand. I do also have it attached to this presentation.
Yes, I would like to share screen, but I'm not allowed to.
Okay, Antonio, I will do that for you right away.
Thanks.
You should be allowed to now.
Yes, perfect. Let me set up the screen first. All right. So good morning, everyone. We are Team Limitless Circularity, and we would like to present you our idea for this hackathon. So what are we dealing with? We're dealing with plastic waste, and according to the Ellen MacArthur Foundation, by 2050, there will be more plastics than fish in the ocean. So as you can see, it's a very pressing issue, and that's why the EU has committed for zero plastic to landfills by 2025, and to increase recycled content in plastics to 25%. And what's another alternative to plastic instead of landfill? Most of the time, it's sent to incineration, as you can see, but this is not the best solution because we're still losing a stream waste of plastic mixed with other material, and it's being burned and it's lost of material, which could be used in a circular way if it was recycled. To get an idea, in Europe, 62 million tons of plastics are consumed every year, and only 1/3 is being recycled. This is of the total amount of plastic being consumed. And out of that 1/3, 20% is being exported for recycling outside of Europe. You can imagine that this is because of high costs in recycling in Europe. So we want to tackle this issue. We have looked at the market and seen the total addressable market, which of course seems like a very inflated and big number, and I'll break it down. The 5.7 billion euros is from all of the plastic generated in Europe that goes currently to incineration. So it takes into account if 150 euros per ton of plastic is what every incinerator charges for this plastic to be incinerated, this is the amount of money that's being lost, let's say, because of that incineration. Next, we have the served available market, which we narrow it down to industries. Why? Because waste is concentrated in the industries. We don't want to go around picking waste from households. This is very small amounts in different places. We want to go for larger amounts for scalability. And this, we find it in the industries. Finally, we focus on one industry, in the hospitals in particular. Taking into account the amount of waste that's generated by hospitals, we assume a 60% collection rate of the total amount of waste, which is realistic. We're not targeting all of the plastic, but part of it, and we'll see how this is possible. And there we would have around 106.8 million euros only for the European market. And why is this not being tackled by other ideas? This is because there are challenges. The work environment in a hospital is busy and stressful, as many previous groups have mentioned, of course, and the waste is contaminated. So many recyclers might not want to take the waste because of that risk of contamination. And this is why this market is unserved, because of this, mainly because of these 2 points. Let's see how it's currently being done. So we have checked and mapped hospitals in Ghent, Brussels, and Antwerp to see the number of hospitals that there are, the distribution, and also the size of the hospitals, to see what are we dealing with. We also made a field trip to the hospital St. Lucas in Ghent. This is the picture that you're currently seeing, to validate how containers are distributed outside of the hospital. And indeed, we validated that there is a lack of space, but enough space for our solutions. There was still, we took the measurements, and there was still space for what we are proposing. In the current scenario, they are compressing general waste, which is great. This we had assumed that they weren't, but anyway, this doesn't affect our scenario. Finally, we reach out to health sector workers from acquaintance and people we might know to get more informed of how the internal work is currently being done. And indeed, there is little to no segregation of waste, and it's a busy and stressful work environment. What's our solution? So we have a stream of different types of plastics, and we identify the main streams. Why? because if we would target all the plastics, then we would need 5 different bins or more to be able to have clean streams. So we focus on the main ones: polypropylene glue wraps and LDP plastic films. Together, they account for 70%, close to 70%, of the total plastic produced in a hospital. And not only this, not only is it concentrated in quantity, but also physically in places, in areas within the hospital that we could more easily target. We don't have to target the whole hospital. So this is also an advantage to limit into these flows. So how would it look? Let's see the image in the hospital, inside the hospital on the left, and outside of the hospital where they usually gather all the waste. So inside the hospital, inside the working space, we would have 3 different bins localized in areas primarily of procedure spaces and the halls adjacent to it to separate the waste, the blue wrap and the plastic film in different bins, and then another bin for the general waste. Also, have in mind that blue wrap is quite easy to identify, so workers don't have to be thinking about where to put it. I mean, the name itself lets us understand that by the color, it's easy to see, and also the particular texture that it has. The same with plastic film. It has a particular texture that can be easily identified. We would also use an alliance with recycling champions within each of the departments in the hospital to increase collaboration and make sure that the system is working properly, making a sort of scoreboards of sustainability within the hospital and the different HR departments in a way competing for who is sorting best, which we have read different articles that there are successful stories of these same schemes. And outside of hospital, we currently have 1 large 40-meter cube container, which takes all the waste. And we would add these 2 additional streams, basically 2 containers that together add up to 7 meters square of blue wrap, and 1 container of 5-meter cube of plastic film. Why 2 containers for the blue wrap? Because we want small bins that can be automatically tilted in the truck. And even though we have more bins, waste of the large bin is now in the smaller bins. So we need to make the idea that we're having the same amount of waste, we're just separated in different bins. So what's coming next? Next, process of shredding and disinfectation. Why? Because UV and ozonification needs to kind of give that ensure the recycler that the waste is going to be effectively clean and no small biological waste could still be in the stream. So we want to make sure that this is not the case. And shredding significantly reduces the volume when you couple it with compression, around 8 times more than if it wasn't compressed or shredded. And also it saves cost further in the recycling process. This is something important because it's still going to be shredded further in the process, but so we're kind of pre-treating it, not only disinfecting it and reducing the volumes, so we have to go less times to pick up the waste, but also we're already doing part of the process that will come after. But the final most interesting part of our solution, it's a mobile solution. So we do all this, the shredding, compressing, and disinfecting on the truck. So we're only gathering the material in bins and then loading them to the truck for this process. And then going to the next hospital to pick up more trash. This is the part where the solution is interesting because it's a sharing economy. It's using the ideas of a sharing economy. And we're not leaving there a compressing machine in the hospital that won't be able to be used by someone else or might be used like 2 times a day and that's it, but we can use it many times in different hospitals. And this is why we call the idea limitless circularity, because we can many times use our own infrastructure that we are proposing to use. So thanks to an outstanding team of engineers that form part of this team, we've been able to make the necessary calculations to confirm the technical feasibility, because I might have forgot to mention this, but this is a proven concept. They have done such trucks in the past, more for compression and shredding, not for the disinfection, but we're sure that this can be coupled, and also transferring. But we've also analyzed the economic viability. We won't bother you with the tables, and we'll simplify it to the findings that we've been able to get. So the current scenario, the hospital is paying about 94,000 euros per year for their waste, their total waste to be incinerated. This is also a size that's the same as St. Lucas Hospital that I showed the pictures. And we evaluated this scenario just to have an idea of what would it be like if we separate rigid plastics from the rest. So only rigid plastics, and we would have one stream of plastics and one stream of rest of the waste. The problem here is that plastics would still need to be recycled, sorted, sorry. So we would still need to pay that fee of 100 euros to be sorted. It's still cheaper than 150 to be incinerated, but it's not as much. And we are already putting here 3 different bins to have films, rigid plastic, and rest of the material. So why not have also 3 bins, but instead be able to segregate the different waste streams and target the main waste streams that I showed in the previous slide of blue wrap and films. So by doing this, we can decrease the costs for the hospital by 8%, while still retaining a profit margin of close to 10%. And saving their saving costs would be 7.6 thousand euros per year for the hospital. What's the roadmap? So we're going to start with targeting Ghent, or a city of such size of around 250,000 people or close. Usually would have around 4 hospitals or so that we can get these profit margins, and the return of investment would be at around, sorry, the payback period would be at around 4 to 5 years if we are working with 4 hospitals. And we can have only 3 bins, so don't complicate the life of the workers too much. And this would be able to work on a small scale in one city, and further on expanding to other cities. That would need another truck and more personnel, but that would be the next steps to come. The last and most interesting step is that we can expand to other businesses, because this is not a solution exclusive for the hospital. I mean, as long as we have a stream that's clean, that we can process and reduce the volumes, then we can go to that factory, process the stream, and take it to either a sorting facility, recycling facility, or a gathering facility. So we can move around. We have identified also some challenges, some risks that might be involved, like a change in technology, a change in material if the hospital stopped using blue wrap or some other disruptive material, or a change in legislation where we could no longer pick up waste from hospitals. And as I just mentioned, it's this mobility that allows us to work with another sector and other streams of plastic. As for opportunities that we identify, plastics, as the previous team mentioned, yes, it doesn't have value. So this is a problem because people aren't willing to recycle because of this low value. But the EU plastic tax in 2021 of 80 cents per kilogram of virgin plastic produced will significantly increase the attractiveness of recyclers to start recycling more material, and companies to start buying higher recycled content plastic. So we are sure that this is a great moment to start this business. And finally, let's not forget about societal and environmental benefits, job creation because of a circular economy instead of a linear economy, sustainability for both the hospital and the supply chain as a whole, and let us achieve our goal of limitless circularity, not only in hospital, but in any application. For this, we only need an initial investment and the right connections to get started. So I would invite you to please meet the team, even though it's virtually, but still, and ask as many questions as you might have, because we're eager to hear them and improve our idea to make it a reality. Thank you very much.
Thank you, Antonio. We have the first question in the chat from Christine. The question is, the EU plastic levy is 800 euros per ton of non-recycled plastic packaging that each member state will have to pay. It is not a tax on virgin plastics. So I think it's more of a clarification than a question.
Mm-hmm.
If there is a question, Christine, if you could just type it into the chat, or I can also give you the floor to express yourself. Do we have any questions from our jury members right now?
Hello, everybody. Thank you very much for your pitch. And I'm afraid I'm going to ask you a slightly different question to the previous teams to set you off guard. If you lose, what's the first thing you're going to be doing?
I think in that case, I'll start off, and then hopefully someone can jump on the answer. We would do, well, kind of similar to what we would do if we would win, just revise and refine the calculations, because it's, of course, this has been done in 2 to 3 days. So there is some refining to do. Make sure that we have it right, that we have the numbers right, and then start seeing if how feasible it is on the technical part and the designing of the truck that we're proposing. I think those two are the start of points, just making sure that this is feasible.
Yeah. Does anyone else want to add something?
Yeah, I would agree, totally agree with Antonio. As he said, this is the product of 2 or probably 2.5 very intensive days that we have been working on this. But of course, we need to refine our calculations. We need to refine also the whole general idea, make sure that it actually is as solid as we think in the calculations, but we are pretty sure we are there. We invested plenty of time on this. And I also think personally that we invested very good time on the roadmap, because we made these field trips. We checked the hospitals, we checked how they actually have the containers distributed, and we made sure that we were filling almost all the gaps for making the idea something real in case, so we can take it to the further step. But yeah, I think it will be something along those lines, and keep pushing hard to make something real in the future.
Thank you.
So we had also a point of clarification in the chat. Another team member, Iona Pasta, mentioned that she was wondering how the blue wraps and films were separated in the truck. And Antonio has responded to this, but it's just to clarify for the audience that the blue wrap and films are already separated, and that there are 2 compartments in the trucks to separate both streams. So if that's unclear, of course, look into the chat. Do we have any other questions from our jury members? No? Do we have any additional questions from Christine? No? Okay, then it appears everything is relatively clear. Thank you very much, Limitless Circularity, for your presentation. I will now stop your sharing of your screen.
Thank you very much.
Wonderful. So just to go back to Flip, if you are still here, we did have one question from Christine earlier that we ran out of time to answer. So just going back to that, it was a question. If you were to sell this service to hospital manager, which pricing would you offer? And did you compare the cost for them? So for the Flip team, if you'd like to respond to that, I will allow you the ability to speak.
Yeah.
More of you are on the.
We saw that. Sorry. Yes, we were waiting for the end to answer. So, Christine, yes, actually, we have all the costs for each unit of solution. However, we didn't propose an overall price, as it really depends on how many bins, how many hospitals would be sharing the unit for recycling. And also, we guess that the costs that we have from the suppliers are really something that can be negotiated. So we compared the overall cost for the chain, but we didn't compare with the actual price that they would invest nowadays in other solutions. So there are details in the slide number 7 of our presentation with all the detailed costs. We also have other offers from other suppliers if you are interested in, but however, our solution is not proposing a global price because it has to be adapted depending on the needs, we think.
Okay, so just so all of the jury members are aware, we will be sharing all of the slides with you and we will go over them as well during the deliberation. Are there any last minute questions? We just have 2 minutes here before we wrap up. Okay, I will take that as a no. I would first like to thank all of our jury members for their time and especially to all of our teams for their amazing efforts in the past 4 days and beyond, because even before that we were doing webinars. So thank you for taking all of the time for that. We will be going into the jury deliberation at 1 p.m. So for our jury members, you can take some time, take a little bit of a repose to reflect and think about the solutions that have been provided today. And I will see you all at 1 p.m. And to our attendees, we will see you all at the closing ceremony today at 4 p.m. So thank you all so much. If you have any questions, please feel free to email me and we'll see you all later.
Thanks, everyone. Thank you.
Thank you very much.
I see you later.